Hello and welcome to this tutorial on basic statistics from Analytics School Online. Today we are going to learn something more about central tendencies, and that is going to be how we plot and what are the positions of our central tendencies, namely the mean, median and mode, on our plots, on our visual representations of our observations. So let's jump right into it. So firstly we are going to consider symmetrical distributions. Now let me tell you about symmetrical distributions. They are evenly or regularly arranged observations around the histogram, where observations are distributed in this manner. Well, this is not a perfectly symmetrical distribution, but this is roughly symmetric. In fact, this is a very good symmetric distribution. In practical cases, you would never come across perfectly symmetric distributions, but if this is the distribution, you'd be lucky that your central tendencies all lie on the same observations. They are all going to be the same value of observations, which is the center observations. Let me tell you something about mean, which we did not discuss in the first video. Mean basically, in an intuitive sense, when you consider the visual plot, divides the whole plot into two equal parts, into two parts of equal areas. So if this is the value of mean, supposedly in this case, then this line is actually dividing these two sections into equal areas. So that is another intuitive meaning of mean. Moving on, now if you consider a perfectly symmetrical distribution, the mean, median and mode must be the same observations. Let us understand why. So if this is a perfectly symmetrical distribution, the mode value would always be the value with the highest frequency, as obvious. Mean would actually divide both of these two sections into equal areas. Again, that would be the mode value. And finally, as median is the halfway value, or the value which you acquire once you move in an order in your data set, halfway throughout your data you would get the mean value. Since in the x-axis our data observations are obviously arranged in an order, ascending order specifically, and then when you come across the 50% value, that should be your median. So if the distribution is perfectly symmetric, mean, median and mode are the same values. But now there is a catch when the distribution is roughly symmetric. Roughly symmetric distributions actually have the same median and mode, because when they are roughly symmetric, the median also does not consider the values other than the halfway value or the value which comes in the center, and the mode, because this is a symmetric distribution, will always have the value with highest frequency in the center. So median and mode will obviously be the same value, but mean might be greater or smaller depending on the observations in your data set. Now let's talk about positively or right skewed data. Intuitively, if you want to understand what a right skewed data is, if you do not consider the frequency of your observations presently, what positively skewed data means is that most of your data points or most of your observations lie towards the right side, or the plot is basically shifted a bit towards the right. That is a right skewed data set, and let us observe our central tendencies in this case. Now basically the mode will always be the value with the maximum frequency. So once your data is right skewed, the frequency of your data would obviously move to the left, because though your data is getting shifted to the right, but the maximum value of frequency does not change, so mode is going to move to the left. Now coming to the median must always lie in the center, because your distribution is not symmetric now and it has shifted to the right. The median would lie in the center of the distribution, and that is obvious. Mode has moved to the left, but median will always remain in the center. And finally, just because more area or more data points are in the right, your mean would obviously try to divide this distribution into two equal halves, because there are more observations with less frequency towards the right and less observations with more frequency towards the left. So a balanced arrangement would obviously make mean lie even further ahead on the x-axis than mode and median. So this is going to be the representation, and the inequality would be as given here. Mean would be greater than median, greater than mode, depending on the x-axis observations. Consecutively, in the negatively left skewed distribution, you can see that there is a negative tilt towards the left side of the distribution. So what happens here is that mode again shifts to the right. So basically you can understand that whichever direction the distribution has shifted to, the mode would shift in the opposite direction. Mode would obviously change because this area wise distribution has changed. So mode will again be towards the right. So mode comes around here, and then median again would try to divide the data set into 50% values. So these values are with lesser frequency and these are the values with higher frequency. So median would lie somewhere approx around here, and again because mean wants to divide the whole distribution in two equal halves, it would be placed somewhere around here towards the left of the median, because these two areas must be symmetrically balanced. So mean would lie here, and considering this concept, our inequality would become that in negatively skewed distributions, mode is greater than median and that is greater than mean. Finally, we are moving forward to the end of central tendencies. This is a very fundamental and basic concept, but it is used critically in analysis of your data. So just keep in mind that mean works for numerical data which should not be skewed. Mean can work for both continuous and discrete data. Median on the other hand can work for numerical data with skewed data sets, also continuous and discrete again. But also median can work with ordinal data. Now mean can also work with ordinal data, but it is not that accurate. So we are keeping the ordinal data in median section. Moving forward, mode can work with all of the data types. But most importantly, when mode is used, it is basically used to get a hold or get the central tendency of nominal types of data. I've given a few examples where we use mean, median and mode. For example, when we often talk about mean population or mean value of finance or economical data sets, we consider mean. When we talk about business incomes or incomes of employees, housing prices and insurance claims, we generally try to centralize them around the median. And finally, mode is basically used where choices are considered. For example, voting, because the person with the maximum votes wins the election. So that is the concept of voting, where we use mode. And then there comes the choice data sets. Wherever you get around choice data set where people start to vote or people start to click on a particular value, that is going to use mode as its analysis for central tendency. And finally, this is the end of central tendencies. There's a lot of other fun and interesting things coming up in our basic statistics course. So learn and grow with us. Hold on, we'll be right back. See you soon. Good day.